In the problem, we are given feed rate which is 250 pound moles per hour. XF concentration of the feed is 0.5, and the enthalpy of the feed which is negative 2000 BTU, and the relationship of S actual to S minimum which is 1.272 times the S minimum, which will be equal to S, and the concentration of XD, or the concentration of the distillate, which is 0.95, and the concentration of the bottoms, which is 0.04. So now we have to plot the steam at the saturated vapor line, because steam is saturated vapor as stated. Next would be we will plot the feed coordinate at negative 2000 to 0.5. Next, we can connect S to F. Then what we will do here is get the equivalent saturated liquid and saturated vapor of the feed by dropping down the feed line to the equilibrium line, then connect a tie line, then go straight up. So we will get the saturated liquid and the saturated vapor enthalpy and the excess coordinates of it. Now we want to get S min. By connecting F to the saturated vapor, we will get, by extending the line upward, we can get D prime min. So here we got D prime min. We can connect the B coordinate to the D prime min coordinate to get the intersection of S and F and B and D prime min. So here we have the XM coordinate. Now we can solve S min by S min over F is equal to XM minus XF over XS minus XM using ELAR, the inverse linear lever arm rule. By computing S min, substituting everything, XM is 0.245, XF is 0.5 over 0 which is a steam, minus 0.245 XM. So by computing S min is 260.204 pound mole per hour. Multiplying this S min to the relationship of the S actual minus SA is equal to S min times 1.272, we can get S is equal to 330.9795 pound mole per hour. Since we have the S actual already, we can compute for the XM of the S. We can compute XM actual by using S actual over F. S actual over F. So substituting everything, we will use the S actual, which is 330 over 250 is equal to 0.5, which is the feed, XM as the unknown, 0 as a steam, XS, concentration of the steam. Now we can get XM, which is 0.21515. By connecting the actual, this is the actual, this is the minimum. Connecting B, the coordinate of the bottoms, X to XM actual, we can get the D prime actual here. Now we have the enthalpy of the distillate by seeing that it is 42,200 as I surveyed it. Now we have this. Next would be getting the rate of the bottoms and the distillate by using OMB and the MVC, which is FXF plus with the steam equals DXD plus BXB. Now substituting everything, we have the values. F as 250, 330 as the steam actual, is equal to D plus B. By solving simultaneously, we can get the distillate rate, which is 111.825 pound moles per hour, and B is equal to 469.154 pound moles per hour. Now, we can solve for the minimum stages. By solving minimum stages, we have to graph downward, starting from the x coordinate of the D prime downward, and so extending a line here and upward, then downward again, extending the line upward, down, extending a line upward, down, extending a line upward, down, extending a line until we reach the bottoms. The minimum stages I have graphed is 5 stages. Next would be the actual plates. Solving for the actual plate, starting from LO or V1, down, up, then getting the tie line, then L1 to D prime, then the intersection V2, down, F, up, then L2 to V2, L2 to D prime, getting this V3, down, until I get to the feed plate, which is here, V3, down, up, there, then here, getting to the feed plate. The feed plate is the 1, 2, 3, 4, fourth plate. Then from here we can connect V5 to the intersection, V5, down, up, down, then until I got the 7th plate. Now solving for HF, the enthalpy of the feed. See, HF is equal to HV minus HL times 0.35 plus HL. HF is equal to 18,000 minus 2,200 times 0.35 plus 2,200. We can get HF, which is 7,730. Next would be the reflux ratio. Reflux ratio, LO over D, which this is HD plus QCD using ELAR, minus 17,600, which is the V1. V1. 17,600, still the V1, and LO. So calculating, RD is equal to 1.5844. It's the reflux ratio. Next, we can get the condenser duty by getting the HD QCD and subtracting the enthalpy of the distillate saturated liquid. We can get the heat used by the condenser. 42,000 is the combined distillate plus the heat used by the condenser minus the heat of the distillate, or the enthalpy of the distillate, which is 2,200. Now, small QCD is equal to 39,800. Multiplying the distillate, which is 111.85 times the QCD, we can get 4,451,630 BTU per hour. Now, we have to find the rates of the L and V of the second plate and the last plate. By using ELAR, simply, we can get 0.95, which is the XD, minus 0.856, which is the V, over V minus L. Simply using ELAR, multiplying distillate, which is 111.825, we can get L2, which is 172.32 pound mole per hour. Next would be V3 over D. 0.95 minus 0.795 over 0.856 minus 795 using ELAR again. V3 is 284.145. And the last plate, L7 is simply equal to B, or the bottoms, which is 469.154 pound mole per hour. Next, to get V7, we have to use the relationship in the plate using F plus V7 equals L6 plus D, and L6x6 minus V7y7 equals negative Fxf plus dxd. So solving simultaneously the values used, L6 is 217.231 and V7 is 355.416. So V7 is 355.416 pound mole per hour. Thank you for listening, and God bless.